Well, welcome to the Ontario High School video podcast series dealing with electrolytic cells as part of our study overall of electrochemistry. When we are looking at stoichiometric calculations for electrolytic cells, um, we're going to look at one more sample problem. So thanks for watching, and we'll move on here. Let's look at a sample problem where we're going to try to find out how many grams of zinc can be deposited on a steel tank from a zinc sulfate solution when a 3 amp current is applied over a 5-day period. So in this particular problem, we're going to solve for the amount of zinc that we can actually electroplate onto a steel tank. To make this simpler for us, we're going to get our time units in the same magnitude of unit. So amperage is a measure of current in coulombs per second, and our time is 5 days. So what we want to do is change our time in days to seconds. So simple multiple conversion here. We take our 5 days times 24 hours in a day times 60 minutes in an hour times 60 seconds in a minute. When we do that, our days, hours, and minutes cancel, and we're left with 4.32 times 10 to the 5th seconds. So this 3 amp current is going to be applied for 4.32 times 10 to the 5th seconds. What we can do now that we know that is we can find the total charge in coulombs, which would be a logical next step for us. So we're going to take our 4.32 times 10 to the 5th seconds. We're going to look at our amperage in its base units of coulombs per second, in this case 3 coulombs for every second, and that is equal to, with our seconds canceling, 1.30 times 10 to the 6 coulombs of charge in this reaction. We found the total number of coulombs of charge associated with this. So we can use our charge now and relate it to Faraday's constant as a conversion factor to find the total number of moles of electrons associated with this charge. So we're starting in coulombs. We have 1.30 times 10 to the 6 coulombs. And for the first time in any of our problems that we've done in this podcast series, we're going to take Faraday's constant and turn it upside down, use it as a conversion factor. So we're going to have 1 mole of electrons on top for every 96,500 coulombs. So we've just taken Faraday's constant and flipped it. When we do this, our coulombs will cancel, and we're going to be left with 13.5 moles of electrons in this reaction. So when we apply a current of 3 amps over a 5-day period, we're going to actually reduce zinc with 13.5 moles of electrons. When I say reduce zinc, we'd be reducing zinc 2+ ion with 13.5 moles of electrons. Since we now have the total number of moles of electrons, we want to compare the number of moles of electrons to the balanced half reaction when we reduce zinc 2+, and that is zinc 2+ plus 2 electrons will yield zinc that is in its reduced form. Now, the way that we can read this is that 1 mole of zinc 2+ will require 2 electrons per mole of zinc in order to reduce zinc to its metal. The moles of electrons used is the basis for stoichiometrically determining the mass of zinc, which is what we're going to do next. So we have our moles of electrons. So we're going to find first the moles of zinc and then convert that to grams. And this should be a very familiar set of stoichiometric steps for you going from moles to grams. So we're going to take our 13.5 moles of electrons, multiply it times the equality that for every 1 mole of zinc, there are 2 moles of electrons. Next, we'll take our moles of zinc and multiply it by the molar mass of zinc, 65.39 grams contained in 1 mole of zinc. When we do that, we'll get 441 grams of zinc. So if we run that 3 amp current through a solution of zinc sulfate for 5 days, we would be able to reduce 441 grams of zinc, and grams of zinc would be deposited on the steel tank. So how'd you do? Well, we've come to the end. And so I want to leave you with just one more quote from Benjamin Disraeli. You all should be familiar with him, a great British statesman. He said this: "Every production of genius must be the production of enthusiasm." I wish you well.